The Martian Marine Corps represents the best of the best of the best on the Red Planet. Like the UN Marines, they are equipped in powered vacuum-rated armor that can do some pretty incredible things. The Martian Recon Marines use the Goliath Mark III and Mark IV power armor, which is not only protecting individuals from the dangers of vacuum and protomolecules, but also from most small arms fire, shrapnel, and even life-threatening explosions and blast waves. Now, we already have the technology and material science to create a suit that looks like this and probably functions in many ways like this, but there is one part of the puzzle that they have solved in the Expanse that we have not. And that is finding a power source that is very efficient and high power to weight ratio. Lithium-ion batteries are basically the go-to nowadays, and they're just too damn heavy and not powerful enough for exoskeletons, which is why most military forces are looking for lighter exoskeletons that aren't powered or have limited power. They're basically waiting for the next battery to arrive, as is many other industries. Not only has humanity in the future solved this whole battery issue, Martian Marines and also Earth Marines generally fight in zero gravity or limited gravity, which means a lot less energy is actually necessary for movement. We're not sure how much a Martian Marine weighs, but let's say here on Earth that suit is 400 pounds, then on Mars, where there is only 1/3 gravity, that weight goes down to just 133 pounds, which makes me think that there's probably a low power mode that's more battery efficient for when you're in minimum gravity or zero gravity. Now, if you're using the power settings at high, then you can also perform some pretty spectacular moves on a low G battlefield. There also seems to be less of an emphasis on taking cover when they're wearing these forced recon marine suits, which are pretty overpowered, but I don't know how realistic that would be. I think I'd still take cover even if I was wearing an exoskeleton. It should also be mentioned that the forced recon marines of the Martian Navy, like the ones we have here in the States, are the very few and very proud. The standard Martian Marine uses Martian light armor, which honestly looks more like motocross armor with some shoulder pauldrons. These lighter armor suits still protected an individual from vacuum and also projectiles. It does make economic sense to have a less intense suit that doesn't need to be fully powered. The Martian light armor, like the heavier suits, had thrusters on them which allowed for increased mobility in zero gravity. Because the worst thing that can happen to a Marine in the middle of a firefight is for them to gently float out of cover. Having a power suit or power source on your suit also gives the average Marine in the Expanse access to a heads-up display and sensors, along with a risk computer which further enhances the abilities of the average grunt. One of the best force multipliers that you can have is making sure that your men don't get lost while they're on the way to whatever mission they're doing. So communication is actually very important here.
So I started as an artist. I got an MFA in sculpture. But I'm here with the NASA booth and the Centennial Challenges, which is really how we got started. NASA has this program, Citizen Inventor Prizes. One of their challenges was for astronaut gloves. I entered it as an artist, and I met my partner now, who was then a competitor, Nikolai, who worked in the Russian space program for Zvezda, the Russian spacesuit provider, for many years. We were competitors the first challenge, and we decided to join as a team the second challenge. We outperformed NASA's current technology and won some money, but then also a lot of support from NASA, and from there we started a business making not just the pressure garment gloves, but also space suits for the new private commercial space industry.
So in terms of a checklist, there are a lot of requirements that NASA has for these competitions, and when you guys are designing these gloves, what were the requirements and how did you guys even surpass their expectations?
So the biggest part of the challenge was to reduce the required torque to bend the pressurized joint. And so NASA went through and measured every single finger joint and the wrist joints, flexion, extension, add and abduction, and measured exactly how much force and torque in turn that it took to bend those joints. And that was really what we designed around, was reducing torque. There are obviously a lot of other considerations with gloves. You want things to be able to cycle for a long time, and there were other measurements that they took. One of the most dramatic ones was a burst test, so they inflated the glove until it exploded. And obviously you want that to happen many times over the standard operating pressure.
And by winning that competition, what does that mean? Does that mean NASA is going to adopt some of those ideas?
Not necessarily. I think it's a good story, though, that, you know, it could have just meant, great job, you know, here's your check, goodbye. But in fact, they've put a lot of effort into building us up as a company. They invited us to Houston to show off our glove technology to engineers, and we have since done some contracting with them. It's a long road to get something into space. It's not a road at all, but it's a real challenge to advance your what they call your TRL, your technical readiness level, to get to space worthiness. But I think it's a great story that NASA really has put the effort and encouragement into bringing us along and trying to have some competition in what has historically been a very exclusive military industrial sort of industry. So.
You guys aren't the David Clark Company. You guys are just two guys, right?
Not to name any names, but yeah.
So you guys have started with gloves and now are moving to full body suits. You guys are working on an IVA suit for intravehicular activity and also some EVA designs. What is the difference there in terms of the design process, in terms of the lessons you guys have to learn to design something like that?
So there's a lot of crossover between IVA and EVA. We're focusing on IVA now because we see a commercial market for that with all the new companies coming online, Virgin and SpaceX being the most famous, but we're actually working with some high altitude balloon companies and some astronaut training centers who are interested in having these suits in-house and understanding them. And there is crossover between IVA and EVA. Both of them need a pressure garment and have a human inside that pressure garment. And there's some basic things that happen with heating, exothermic body temperature regulation, and anthropomorphics trying to overcome how body moves versus how the balloon that surrounds the body moves. So.
And you guys behind us have an example of one of your IVA designs. You come from the designer background, so textiles and fabrics and material science, that's something of interest to you?
Yeah, absolutely. I would say that I am the materials guy in the team. I have a little bit more knowledge of the American market and newer technologies of materials, and Nikolai has a lot more knowledge of the flat patterning and restraint techniques that it takes to develop movable pressurized joints. You'd be surprised that there's very little design in an aesthetic sense that goes into this. It's almost entirely functional, and we get that question a lot, like how much do you want this to look sexy and how much are you just like, why is it orange and things like that. And it's really, that's a functional aspect of a suit, and I imagine in the future that we'll have more aesthetic considerations, but for now it's like form follows function, as it were.
Function is very important when you're talking about something that's keeping someone alive in space or up in a balloon. So when talking about the future, where might someone see a Final Frontier design spacesuit, in a commercial application? Who are you talking to, and what's next?
So we're excited to be working with our first real customer, Zero to Infinity, which is a high altitude balloon company out of Spain. They hope to fly humans next year, 2014, in what they call their mini balloon, up to like 30 kilometers, which is 90,000 feet or so. So they absolutely need a pressure garment as a redundant backup pressure layer at that altitude. I think it makes a lot of sense for us to be working with high altitude balloon companies because adding a rocket into the equation just adds a whole lot of other complexities, G-forces and flame resistance and vibrations that you don't have in a balloon. So it's a great first step for us, but we'd like to move on to rocket companies and eventually, provide the EVA suits for Bigelow Aerospace or whoever else needs them in the future.
That's so awesome. Thank you so much, Ted, for telling us your story, for being here at Maker Faire and letting kids actually try out your gloves.
Yeah.
It's just two guys from Brooklyn. Well, one guy from Russia originally.
Yeah, exactly.
And
we're growing. We have 4 people in our company now, plus some interns, and but yeah, just a couple guys.
It's a great startup innovator story.
NASA is beginning to recruit volunteers for the first simulated mission to Mars. There will be 3 such missions in all, and the first will launch in the fall of 2022. In each of them, the team of 4 people will have to spend a year in a 3D printed module Mars Dune Alpha area of 160 square meters. Volunteers will have to experience all the challenges of a possible mission to Mars, including resource limitations, equipment failure, communication delays, and other environmental stressors. Spacewalks, scientific exploration, robot control, food growing, maintenance, hygiene perceptions, and all other factors of a possible trip to Mars will also be simulated. The experiment is open to healthy and motivated non-smoker and U.S. residents between the ages of 30 and 55 with a degree and experience in one of the STEM fields, or who are professional pilots. Read more about colonizing Mars in the issue here at the link in the tip.
This spacesuit, built in 1974, was reported to cost between $15 and $22 million. Today, that would be about $150 million. Having not delivered any new mission-ready extravehicular suits since then, NASA is running out of spacesuits. In fact, NASA are down to just 4 flight-ready EVA suits. Since 2009, NASA has invested more than $200 million in spacesuit development, recently unveiling the XEMU prototype. But NASA still does not have a new fleet of spacesuits. So why has it taken so long for new spacesuits to be built? And what makes them so expensive?
Spacesuits are so expensive because they're complex, human-shaped spacecraft. Think about them in terms of spacecraft, not as work clothes. A spacesuit has to protect an astronaut from the vacuum of space, from radiation coming from the sun and other bodies, and it has to protect against fast-traveling particles that are traveling up to 18,000 miles an hour that could penetrate the suit. They provide oxygen, communications, telemetry, and everything else that a human needs to survive, all rolled into one tiny human-formed spacecraft.
But the spacesuits NASA currently uses are more than 40 years old. 18 suits were developed for the Space Shuttle program in 1974 and have vastly overworked their original 15-year life design. Suit number 1 was only used for certification, while Suit 2 was destroyed during ground testing. 2 suits were lost in the Challenger disaster in 1986, and another 2 in the Columbia disaster in 2003. The most recent spacesuit loss was Unit 17 during SpaceX 7's cargo mission mishap. The exact cost to replace this unit is unknown, but estimates range as high as $250 million. For the remaining 11 suits, the damage is mounting, with 7 in various stages of refurbishment and maintenance. That leaves only 4 flight-ready spacesuits aboard the International Space Station. In fact, NASA's first all-female spacewalk was postponed because the space station had only 1 medium-sized suit. This milestone was finally achieved when NASA sent up a medium torso shell to fit the existing larger suit. NASA has invested about $250 million developing the XEMU suit for its Artemis program, which plans to take humans back to the surface of the Moon by 2024, with a view to eventually go to Mars. With that goal fast approaching and the number of existing spacesuits dwindling, NASA engineers face a new kind of space race.
There is absolutely a sense of urgency, not only because of the number of suits itself is relatively small, but the individual components that we use to keep the suits healthy and moving forward is also dwindling. A great example of that is the carbon dioxide sensors. The design that the current suits fly is a heritage design, some of the components of which are no longer produced. Some of the vendors that made those components no longer even exist. And so today, the CO2 sensor is a great example of a component where a replacement design that will work for both the existing suit and the new suit, basically be a drop-in replacement that's compatible with both suit designs.
These people-shaped spacecraft are packed with complex components, but the most expensive parts are subject to debate.
The most expensive component of the spacesuit are the gloves. The gloves are the most complex because the astronauts need them for manual dexterity to do meaningful work in space. You see the interior, you see a system of pulleys and strings that hold it together. And then on the outside of the glove, you see the system of heat radiators that allow the astronaut to keep their hands warm.
The gloves are an amazing and intricate component, but at the end of the day, the pressure garment, including the gloves, is actually less expensive than the life support system. The backpack that is worn on the back of the suit is a highly compressed set of technologies that do everything from maintain temperature to remove carbon dioxide and continue to provide pressure inside the suit itself. And I think in the end, several of those components are each more expensive than most of the other garment components like the gloves.
But even these expertly engineered suits can go wrong. In 2013, European Space Agency astronaut Luca Parmitano reported that his helmet started filling with water.
That stuff on your forehead is not sweat? No, it's not. Oh, I see.
Hatch coming open.
Copy all, Chris. You could have some towels ready, that would be great.
In total, almost 1.5 litres of water leaked into his helmet, threatening to drown Parmitano mid-spacewalk. But considering that NASA's Apollo-era spacesuits allowed 12 humans to walk on the moon 50 years ago, and considering the Space Shuttle-era suits have been used on over 200 spacewalks, is such a large investment in new spacesuits needed?
Well, that depends on what you're going to ask the astronauts to do. Walking on Mars is different from walking on the moon. It's a different environment, it has different hazards. So when you're picking these assignments for astronauts, you have to take into account, do you want the astronaut to be able to walk, bend over, pick up things, or will he or she be carrying something? So you have all those considerations that have to fold into that design.
We believe it is a necessity. Some of the components and some of the design concepts are no longer consistent with our values and expectations in terms of the quantity and distribution of crew members that we fit. I believe that, yes, the investment is appropriate and worthwhile. All those dollars get spent here on the ground, and they're returned to us in ways that ultimately yield benefits for all of humanity and for the taxpayers here in this country. We are also lowering the barriers to entry from a commercial perspective, getting more companies involved, getting more companies competing and innovating to try to continue to reduce that price.
In an effort to develop technology at lower costs, NASA often sets design challenges for innovation, sometimes partnering with the designers and companies who impress the most. In the 2009 Astronaut Glove Challenge, Ted Southern bagged the second-place prize of $100,000. He and his partner, Nikolai Moiseev, a leading Russian spacesuit engineer, used their winnings to form Final Frontier Design.
We as a business were formed about 10 years ago and have worked with NASA on components of EVA suits for that whole time. NASA's our biggest customer, and we've delivered prototype components for the suit, including a glove, elbow, shoulder assemblies, parts and pieces. But just over the last 2 years, we've focused on bringing the whole system together.
And Final Frontier plans to build its own EVA suit much, much cheaper than NASA's.
We intend to deliver flight-level suits with similar requirements as NASA's. Our suits are made with the same material as the suits that NASA used down to the mill. Traditionally, spacesuits are very expensive. I expect our suit development will be in the multi-million-dollar range, but I hope that our suit EVA system will be around $2 million a piece or less.
Even though NASA has not officially released the unit price of the new XEMU suit, it's safe to say their costs will be much higher.
If we were to take the design of the suit we have today, if we were to reproduce copies of that suit, we believe that would cost us in the range of 15 to 25 million per unit. But we do believe that the design that we're developing today with the XEMU should not only stay within that range, we actually believe that competition and the innovation that we've fostered will actually drive that cost lower per unit.
How does NASA's spacesuit costs compare with other countries? Russia's equivalent of the EMU suit is called the Orlan. Like NASA, it also has 4 suits aboard the space station, but it also has reserves, both at the Cosmonaut Training Center in Star City, Russia, and at Johnson Space Center in Houston, Texas. According to Nikolai Moiseev, who is one of the few engineers to work on both America's EMU and Russia's Orlan, unlike NASA, Roscosmos has continually developed new generations of spacesuits. Moiseev personally participated in the development of 5 generations of Russian spacesuits, and estimates that 24 units were made between 1997 and 2002, with a further 24 units made between 2002 and 2019. Roscosmos is also developing a new EVA suit for Russia's first proposed moon landing by 2030. With Russian technology in a cycle of constant development and American EMU fleets continuing to age, more commercial opportunities could become available for private companies like Final Frontier to develop spacesuit technologies at lower prices. In 2017, Elon Musk revealed the SpaceX IVA spacesuit. Although this intravehicular suit is only for use inside the spacecraft, Its 3D printed helmet and custom-made garments are a glimpse into the future of commercial spacewear. But is there an actual need for cheaper spacesuits? Or is space exploration unavoidably expensive?
I believe the world needs cheaper spacesuits because, in my opinion, it's inevitable that we will expand past the surface of the Earth. We need to take advantage of the resources of space to keep our planet healthy and alive. So whether it's spacesuits or rocket technology or means of living in microgravity, all of these things I think are important for the future of humanity.
It's one small step for man, one giant toast for NASA.
U.S. engineers used PolyJet 3D printing technology to build robot prototypes from polymeric materials. Thanks to the ability to print multiple photopolymers simultaneously, the technology makes it possible to create complex structures from multiple polymeric materials with different properties in a single printing sessions. First, engineers designed and printed diodes and transmitters powered by hydraulics and pneumatics, and then they demonstrated their use in control circuits on hydropneumatic robots. One simulated a turtle, and the other was a 3-fingered robotic arm that engineers used to control the gamepad of an NES game controller. Using a pre-written program that controls the Robo-Roku fingers pressed on the buttons of the controller at specific points in time, the engineers were able to pass the first level of the game, Super Mario Bros. The Bill Gates-backed Vicarious Surgical is going public through a $1.1 billion deal with SPAC and plans to reach $1 billion in annual revenue in just 6 years. The company's developing a tiny alien-like surgical robot with a VR headset, 2 arms and a camera that can be launched inside the abdomen and perform operations that cannot be done by anything else in the world, including the famous Da Vinci surgical robot. The robot reaches in through a 1.5 centimeter incision and uses 2 arms with 9 degrees of movement as well as 28 sensors on each arm. The micro arms fully replicate the range of motion on the surgeon's hands, including shoulders, elbows, and wrists. The stereoscopic camera transmits 4K quality images of any of the surrounding surfaces to the surgeon. Sensors allow the force level to be adjusted via feedback, and the robot arms can work both under and over it, and generally at any angle relative to its torso. The iBotics Research Center decided to find out whether one operator can control different telepresence robots. It turned out he could. In the experiment, an operator in the Netherlands first performed tasks in Switzerland using the animal robot, and then switched to the home robot Eve in Norway. The study was conducted for the Anna Avatar X Prize event. But another thing I wonder is whether it will become the basis for the emergence of a new profession, remote operator of any robotics around the world. Facebook recently announced the Droidlet, an open-source platform for rapid development of smart robots. It's a modular program for rapid prototyping. On it, for example, users will be able to test different computer vision algorithms with their robot or replace one model of natural language understanding with another. At the same time, it's possible to test hypotheses in real world as well as in Minecraft or Habitat. Facebook has stressed that with Droidlet, engineers can use all the latest advantages in artificial intelligence and build machines that can effectively respond to complex voice commands. Droidlet has an interactive control panel that includes debugging and visualization tools, as well as an interface for real-time bug fixes.
The EXO is a wearable robot to help humans safely lift up to 200 pounds without strain or injury. It can amplify your strength by a factor of 20, so 100 pounds feels like 5.
What are some of the main industries that you expect the EXO to be adopted in?
It ranges from construction to manufacturing of automobiles and planes to warehousing and logistics. If you think about it, any job on the planet where humans are having to do physically demanding work, the exoskeleton is a candidate to help out.
When people think powered exoskeletons from science fiction, they probably think military applications. Now, is the EXO designed for that, or will it be in the future?
So the exoskeleton has its roots in the military because the military helped with some of the funding to get us started way back in 2000. But this is not a tactical machine. This is a logistics machine. This is a machine that is intended to allow you to safely lift a lot and do a lot, but it's not intended to be something that's going to be equipped with armor and to be on the front lines.
So right now it feels probably like 12 pounds in each hand. If we were to lift a box, for example, you could feel it compress. So we've amplified the person's strength, but they can still feel the nuances of what's happening with the object. Right now the robot multiplies my strength by about a factor of 4. And right here we have some settings. I can go into what's called heavy lift mode. And so that multiplies my strength by even more.
And although I can't use the EXO at the moment, I can see how some of the tech inside it works in isolation.
Safety first.
Right.
Okay, so this is 30 pounds.
That's 30 pounds on the end of our arm, yeah. What is your experience right now? Is it a little sluggish? Is it a little...
Yeah, it's a little slower than my actual movement of my arm. It's not super responsive, but it's much lighter than lifting 30 pounds just on my own.
Bring that back down towards your hip, and we're gonna start to amplify everything that you do, all right?
Oh, wow.
There you go, and you're all the way up.
That is responsive, wow. Hi, I'll give you a little wave. So if I get tired, release the trigger and wow.
Totally hands-free, right?
It just locks it. It feels, so I can feel a slight vibration. This is crazy because 30 pounds is just not achievable to be able to do this kind of movement without the help of this arm.
And then if you had ever had a problem, we would hit the E-stop and it would fall like this.
Oh, okay. So it doesn't, so when you hit the E-stop, it doesn't just drop. Now, why is that? It's got a safety latch.
So we've got some safety mechanisms that when power cuts to the system, we let things fall slowly like that. It sort of melts.
So this is the same degree of movement and freedom that I would get in the EXO.
Absolutely, absolutely. Now imagine that over your whole body, your arms, your legs, everything being that much stronger. Can you believe it?
I will be the bionic woman finally.
Absolutely.
My dream is true.
Perfect.
All up, the EXO is 300 pounds, but when you're wearing it, it actually only feels like 5 to 10 pounds because the robot's dealing with all that weight. With 24 degrees of freedom, the EXO can also move just like we do. And it runs hot swappable batteries, so you can run this thing for around 8 hours at a time.
The cost of a machine like this is about $100,000 a year for what we call a robot as a service model. So we will provide it to you for a period of time. We maintain it, repair it, service it, upgrade it. And if it doesn't perform and show up every day and do its job, you don't pay us. So we make it very affordable.
So as the human operator in a machine like the EXO, it feels like the human is potentially the weakest link.
That's a great perception, but I'll tell you, I think the human is actually the strongest link.
Okay.
Because the human has the intelligence, the instinct, the reflexes to be able to do all the things that we start learning from birth how to do. And the beauty of this machine is you don't have to think about wearing it or operating it. It just naturally flows with you. You know, machines are very good at doing something with a lot of precision. Better than humans in some instances for precision. So if you think about being able to have the precision of a machine partnered with the intelligence of a human so that you can get just that extra level of precision in a free-form movement, like using a saw to cut a straight line. I think that's where the real opportunity is for us in the future. We're focused on how 1 + 1 can equal 3 or 5 or 10, where you take the best of both worlds, the best of what humans have to offer, which I think is our intelligence, coupled with the precision, strength, and endurance of machines.
Now all you need to do is strap some jetpacks to this and it becomes the true Iron Man suit. You do realize this has to be your next project.
I'll respectfully decline to comment on that one.
So these covers are actually going to be on the finished version. So they're going to give it a more polished look than the guts that you saw of the EXO. But it's actually kind of cool. You guys got a sneak peek of everything that's inside before it gets finished off with these covers. And it's going to look more like this when it ships, very Transformers-like. And the EXO is going to be available in January 2020 with the first units being shipped to customers in alpha form and to the military. Thanks so much for watching Beta Test. I hope you enjoyed the episode. If you did, give it a thumbs up and subscribe, and make sure to stay tuned for more cool robots and exoskeletons. I feel feel so badass right now. This is amazing.
The next exoskeleton looks really futuristic and was developed in Japan. The Hybrid Assistive Limb, or HAL, was already designed in the 1990s and has since been modified and improved. The suit is already quite widespread and used in 130 different medical institutes in Japan. There are even some being used in Germany. It functions as follows. During movement, nerve signals are sent from the brain to the muscles, producing biological signals that the robot suit can perceive via sensors on the skin. As a result, the exoskeleton moves at the same time as your muscles and can therefore support you perfectly.
Of the powerful armor for soldiers are their Russian colleagues. They created a military uniform called Ratnik 3. It's the third generation of an exoskeleton, while the one used in the present is only a passive protection. It's simply a bulletproof suit which does not enhance the movements of the soldier. But the prototype of an active exoskeleton resembles the American analog, but instead of the newest materials, it concentrates on something else. Instead of lightness and mobility, the focus is on the power. The suit of the future warrior of the Russian Federation is much more massive, but the soldier inside it doesn't feel any discomfort because the uniform plays a role of an exoskeleton and multiplies the human force. Shooting from a heavy machine gun with one hand, carrying weights and ammunition up to 330 pounds or 150 kilograms, that's only a part of what the Ratnik 3 will allow soldiers to do. This exoskeleton will be made of titanium and use an electric engine which can run for a day without recharging. Also, a system of vital sign sensors is supposed to be embedded in the suit. In addition, the foot gear is planned to be equipped with special mine detectors. The suit is expected to be working in extreme temperatures from 122 to negative 58 degrees Fahrenheit or from 50 to negative 50 degrees Celsius. Have you ever heard of severe Russian winters? Well, this suit will endure them without a problem, as well as a scorching summer in the desert. The British military armor developers rely more on mobility rather than power. It's just that the communication means sensors, computers, they all need to be coordinated and recharged. And the batteries and remote controls may weigh quite a lot, while in battle, even a second of delay may cost a life. A British company named Intelligent Textiles has found an answer. Its scientists have developed a fabric that works like a flexible computer. How would you like a keyboard on your jacket sleeve? And no breakable or fragile elements, only elastic, flexible, and very durable textile. Would you like to have such a computer jacket? But there's something still more important. The computer suit has a spread signal system. This means that even if the fabric is damaged, the fibers search for an alternative way to transfer the signal through the intact parts of the costume. And while the exoskeletons in the USA and Russia are just being introduced into service, the British have conducted experiments on creating such a cool military uniform as long ago as 2012. However, Great Britain does have a uniform concept that, in terms of protection, is just as good as the American or Russian uniforms. The project is called FIST, Future Integrated Soldier Technology, and it has been mostly integrated into the life of a modern British soldier, as its development had been started in the distant 1994. And in 2015, it was already in the phase of implementation. About 30 to 35,000 of Her Majesty's warriors are expected to be equipped with these suits as soon as in 2020. Instead of the exoskeleton, the emphasis is placed on the electronics. A map system, target locators, effective rangefinders, electronic optical converters, all these tools are aimed to help the soldier get the fullest information about his surroundings. And because the electric modules are multiple in this suit, the new generation batteries will be an important part of this uniform. Small, but with a storage capacity sufficient for many hours of uninterrupted work on all these systems. The suit also has a thermoregulation system, and the helmet has several lenses, which give the analysis of the environment in enlarged spectrum and with augmented reality.
I am Trace, and I'm here with the creators of the Tesla suit. Dimitri, and Serge is in the computer. Hey guys.
Hi. Hello.
So this is the Tesla suit. What is it exactly?
This is a VR haptic suit that transmits tactile sensations from virtual reality and games to your body.
Okay, so if I were wearing this, I could feel what was going on in a game, like if somebody punched me, I'd feel it?
Exactly.
Oh man, that sounds awesome. Can I try it? I want to try it.
Let's do it.
So how does this suit work? It's haptic technology, but what does that mean?
Yeah, so we use neuromuscular stimulation,
Okay.
which it means, for example, when I'm lifting my arm, it means that our brain sending electric pulses to our muscles.
Yeah.
So basically with Tesla suit, we're using the native body language technology.
Okay, so it kind of speaks to our body in a language our body understands.
Yeah.
So it makes our muscles kind of contract like they normally would. It pushes the sensors in our fingers the way they would normally be stimulated. So what's in here that's going to make me feel sensations then?
There's a matrix of electrodes. It's a textile, so there's no wires, no cables. So by sending different types of electric pulses with different power and different frequency, we could simulate different types of touch, from something crawling on you to, at some points, even wind. Hot and cold is coming to DK1 version, and even force. So,
wow.
So you could feel the weight of the virtual glass.
So in this version, I'm going to feel my muscles contract and things like that, but in future versions, what are you going to incorporate?
Heat sensors.
And then biosensors as well, like heart rate monitors?
Yeah.
It went from being like somebody's hands like this to kind of spread out but vibrating. So it kind of spread everywhere.
When you see the TV,
Yeah.
so there's 24 frames, so when
Right.
they're moving fast. So once you take a one frame, it's a one photograph,
Yeah.
So but once you put them in sequence, it make an
moves.
action,
Right.
So this is the same as we did here. So we could actually create your own patterns, and now with Tesla suit we could transmit the tactile sensations over distance.
Okay.
So it's a next step in a whole
Like
technology
human
development.
connection. So the Tesla suit has some obvious applications for the future. It's kind of using my own body's physiology. I mean, I can see so many different ways that this can go.
Now what they've developed is a facial interface kit, which can be placed on any VR headset using Velcro, and this facial interface kit can provide heating and cooling sensations depending on your interactions with the virtual world. I'm really looking forward to trying this one out. In the box you get this Bluetooth module which contains a 1900 mAh battery, and this serves as the power to the facial interface kit and the communication link to your PC using Bluetooth. The module has a single button to turn it on and can be recharged using a USB-C cable which is included in the box. And then we have the ThermoReal facial interface kit itself. I'm pretty sure this is a standard Vive facial interface kit which has been modified to add these three thermoelectric devices. Tegway are stating that the ThermoReal can intensify a virtual reality experience by adding hot and cold sensations as well as pain, which is apparently a mix of both hot and cold at the same time. This is going to be interesting. Apparently it covers a temperature range of 4 to 40 degrees Celsius. I'm going to be putting this on the Oculus Quest using the VR cover replacement interface kit, as this can hold the ThermoReal in place using Velcro. It's so cool that it gradually gets colder the further you move into the room. Man. Oh, that is unbearable. Get out of here. Let's get out of here. Oh, man. I didn't expect it to be so extreme. I thought it would just get a little bit cold or a little bit warm. But this is actually getting legitimately hot. It feels like it's super hot on my head and really cold. Super hot. Oh my. I don't even need to grab it. Even if I just put my hand over it. Oh, I can feel the heat. And it's almost unbearable. You just can't do it for very long. I feel like if you did it for too long, you might actually hurt yourself. Wow. Okay, after doing that, I definitely want to step into the shower. Oh, that's beautiful. That is beautiful. And I can turn the heat up, make it a hot shower. Or a cold shower. It would be nice if you could use the vest at the same time to feel the raindrops. I think I remember them demoing that, but I couldn't get that to quite work in my testing. But yeah, that's cool. I like the shower. So,
transparent aluminum was once pure science fiction, a technical term used in a Star Trek movie from the 80s. In the movie Star Trek IV, The Voyage Home, Captain Kirk and his team go back in time to acquire 2 whales from the past and transport them back to the future. Scotty needed some materials to make a holding tank for whales on the ship, but had no money to pay for the materials. So Scotty uses his knowledge of 23rd century technology and the manufacturer's computer, and he programs in how to make the transparent aluminum molecule.
Transparent aluminum?
Which could allow the manufacturer to create aquarium tank walls 1 inch thick instead of the traditional 6 inches thick. Now the words transparent aluminum sounds like it's 100% pure see-through metal, but in actual fact it's a mix of aluminum, oxygen and nitrogen in the form of white powder. The powder then gets packed into a mould in the shape of the desired part. The mould is then subjected to extreme pressure and then heated to 2000 degrees for several days. The surface of the final part comes out cloudy and has to be mechanically polished to make it optically clear. It starts to sound less impressive and less sciencey fiction when you hear how it's made, but the end result is still very impressive. As transparent aluminum, which is also known as ALON, can be turned into very damage-resistant glass and can be used to make highly bullet-resistant armour for military vehicles. Transparent aluminum armour is made of 3 layers, just like bullet-resistant glass, 2 panes of glass and a middle pane of polycarbonate. The main difference is a .50 caliber bullet can penetrate 6 inches of traditional bullet-resistant glass, but cannot get through about 1.5 inches of ALON armour, which means you can provide soldiers with far better protection on military vehicles for far less weight. ALON is being considered as a replacement for windows on the International Space Station, to replace the traditional laminated glass they use now, as the laminate scratches easily, which ruins the clarity of the viewports in windows. But ALON does not need to be laminated, and it does not chip easily like glass. Transparent aluminum armour is light years ahead of glass, but it is currently very expensive to make. The bullet-resistant glass currently in use costs around $3 per square inch to produce, compared to the $10 to $15 price tag for the same size piece of transparent aluminum. As more industries switch to transparent aluminum for their needs, the price of the product could drop to a point that makes it cheaper to use in other applications. Providing windows for deep space and undersea vehicles are among the top planned uses.
And that new control method is mind control. It sounds crazy, right? But this is a real product called NextMind, which is a brain-computer interface. It's currently available as a development kit, and the team at NextMind kindly sent me one over for me to try out. It's a small and lightweight device at just 60 grams and can easily be clipped onto the back of a baseball cap or a head strap of a VR headset. It contains an internal rechargeable battery which lasts up to 8 hours and is charged via USB-C. The device features 9 comb-shaped sensors which make contact with the back of your head and can read the signals from the visual cortex of your brain, which are then sent to the PC via Bluetooth, giving you the ability to control digital actions with your mind alone. So now I'm going to try and explain how this technology works in the most basic way I possibly can. And that starts with a mind-blowing fact that I recently learned, and that is that you don't actually see with your eyes, you see with your brain. For example, this video that you're watching now, your eyes are just the middleman between the images of this video and the visual cortex of your brain. So when I'm wearing the NextMind device and focusing on these objects in both the flat screen and VR experience, each of these objects has a unique signature pattern overlay, which is being read by the visual cortex of my brain. These signatures and signals in the visual cortex can be picked up and identified by the NextMind device, which are then sent to the PC to process them and translate them into an action. The NextMind is a non-invasive device which just reads the signal from your brain. It can't actually write to the brain, and you can opt in and out of any data that you wish to share with the company. Tech like this seems like complete science fiction, but it might not actually be as far into the future as you might think. Because NextMind aren't the only ones that believe this technology could change the way we work and play forever.
Hello everybody. New technologies are being used in all areas of human life, and the army is certainly no exception. But we aren't just talking about modern military equipment, like tanks and drones and submarines. We mean personal protective equipment. In this video, we want to show you the coolest inventions among modern armor systems. Some of them are still in development, as some of them are already available for purchase. So, you want to know how a soldier of the future would look like? Well, let's get it on. Exoskeleton Protection System. Revision Military started as a manufacturer of ballistic eyewear, then moved to personal protective equipment like helmets and electronic devices, and in 2015 decided to start developing exoskeletons. In the US, there is a program known as the Talos Initiative. It's a Special Operations Command project to develop a robotic exoskeleton. Many companies are working on this initiative, but the model from Revision Military is the most realistic so far. But not because it doesn't look like some kind of science fiction armor. It actually does. It's just that this is the most successful design so far. The power suit combines passive and active exoskeletons. The flexible artificial spine of the system bears most of the weight of the armored plates and helmet. The load is redistributed to the exoskeleton legs, equipped with electric motors. In addition to the motors, the battery powers the communication equipment, a night vision device located directly in the helmet, and the liquid cooling system. The company claims that the suit has already been tested under simulated combat conditions, and soldiers wearing exoskeleton suits perform as good as their brothers in arms. Perhaps in a while these suits will enter mass production, marking the biggest upgrade in infantry in the last years. Explosion-proof suit. You may remember this old-fashioned movie cliché. Something explodes behind the protagonist, but he just keeps walking without even turning around. He's just too cool to look at the explosion. You must have seen such scenes. Meticulous experts argue it's simply impossible to do that in real life, because the heat and the noise would be too powerful. At best, you'll get clogged ears, and at worst, there'll be some burns too. Well, it seems that the Russian state corporation Rostec accepted the challenge. They developed an unusual protective suit, which according to the creators can withstand even ammunition explosions. To prove it, the designers demonstrated that you can even wear it to a minefield. An employee of the testing group of the Central Research Institute of Mechanical Engineering walked through the mined area in the middle of explosions and fire. But did not suffer any damage, maybe just got a little dirty. Unfortunately, we've not managed to find out what kind of explosions this invention can withstand. Maybe the information is classified. Reportedly, the explosion-proof suit will soon start to be used by the Ministry of Defense of Russia. Third arm. Many of you have probably had this feeling when two arms just aren't enough. Moreover, during combat operations, a third arm could really come in handy. The US Army Research Laboratory has found a solution. They created a device that would help soldiers to hold heavy weapons. Marines have always moved, talked, and performed all kinds of tasks while carrying over 13.6 kilograms of weapons. They also wear heavy uniforms and carry auxiliary weapons. It's a significant load for any person, and it can affect the performance of the soldiers during a combat mission. Therefore, the possibility to ease part of the load on soldiers seems so appealing. According to one of the creators of the device, the third arm does not need batteries, has a low weight, and evenly distributes the loads of the weapons. In fact, the third arm is a mechanical device attached to the belt at one end and to the rifle or machine gun at the other. To reduce the weight, the arm is made of carbon fiber and weighs about 1.4 kilograms. If necessary, it can even free the soldier's hands completely. By the way, the third arm has already been tested with a number of heavy machine guns, and the developers were completely satisfied with the result. Ratnik 4. For the first time, this Soldier of the Future equipment with a titanium exoskeleton and an electronic visor was shown in Moscow in June 2017. According to the developers, Alyosha, which is the codename of the project, will be the 4th and 5th generation of the combat system Ratnik. Apparently, the development is going to be really impressive. Alyosha's boots will be equipped with mine detectors and a radio suppression system, as well as inserts that will protect soldiers from bullets and shell fragments. The armored helmet will be equipped with a night vision device, a target designation system, a special mask instead of a usual gas mask, and a flashlight. This helmet will be able to project information about the situation on the battlefield in front of the soldier. The only thing missing is Jarvis. Oh, wait, well there is something similar.
Alright, what do you say?
I have indeed been uploaded, sir. We're online and ready.
Anyway, rumor has it that the bulletproof vest will be equipped with a friend or foe identification system. Combat protective coveralls will monitor the physical condition of the soldier, and if necessary, even provide him with first aid. Information about the health condition of the soldier will be projected on the electronic visor of the helmet. Note also that the coverall bearing frame will be equipped with a quick release lock. Therefore, the soldier can take off the exoskeleton in case of need and move on without the suit. Ronin Ballistic Helmet. This helmet looks like a cross between a Star Wars prop and an intricate airsoft mask, but it's actually a new generation of military outfits. The Ronin Kevlar helmet protects the fighter from Kalashnikov bullets, shell fragments, and open flames. It's also equipped with an individual air conditioner with poison gas filters and transmits signals to other helmets to determine whether friends or foes are wearing them. It is claimed that the helmet also has an infrared detection function for close combat in the dark. However, despite its many features, the total weight of the helmet is only 4.85 kilograms. As we've already mentioned, the Ronin is made of Kevlar and is equipped with additional 7mm thick cheek panels, which are held in place by neodymium magnets. The use of magnets allows you to quickly disconnect one of the cheek plates if you decide to press your cheek closer to the gun for better aim. Kantanka exoskeleton. The African continent has something to offer to the global military-industrial complex. The Kantanka Technology Center of Excellence, part of the Kantanka group of companies, showed its latest creations, an armored vehicle and a unique combat exoskeleton. Despite the rather clumsy appearance and almost complete absence of smooth lines, these exoskeletons not only protect the soldier, but also allow them to fire without touching the weapon with their hands. Does it sound fantastic? Agreed. However, for this purpose, special engines on the back of the soldiers control an automatic rifle. Anyway, that's what the developers say. However, the soldiers in these exoskeletons move very slowly. Well, this is probably the very first version of the device, so there wasn't much time to improve. That's why the development looks so ugly. Note:
there are two main parts of a spacewalk suit. The first is the pressure garment, and next is the life support system. Pressure garment is the human-shaped portion of the spacesuit that protects the body and enables mobility. The primary components of the pressure garment are the cooling garment, upper torso, lower torso, and the helmet. The cooling garment is the first piece of the spacesuit that an astronaut puts on. It's made with stretchy spandex material with water tubes running throughout it. About 300 feet of tubes are woven into this tight-fitting garment. It covers the entire body except for the head, the hands, and the feet. Chilled water flows through the tubes near the wearer's skin to regulate the body temperature and remove excess heat during the spacewalk. This is extremely important, being the spacewalks can last for many hours. Then vents in the garment draw sweat away from the astronaut's body and help with circulation inside the spacesuit. Next is the hard upper torso. This is lightweight but strong and connects inside the suit with the appropriate systems in the portable life support system. The upper torso of the new exploration suits will have a rear entry hatch to allow astronauts to climb in from the back of the suit. Being that astronauts must work in the suit and pick up objects while wearing the suit, the gloves protect astronauts from the space environment and are made so the spacewalker can move their fingers easily while working outside the ship. Being the extremities, like the fingers, are the part of the body that gets the coldest the quickest, gloves on spacesuits are equipped with heaters to keep the fingers warm while still allowing dexterity to use the tools. Next is the lower torso section. This section of the suit is made up of the spacesuit's pants, boots, and lower half of the waist closure. The part at the waist, called the waist bearing, helps astronauts move and turn. A metal body seal connects the lower portion of the torso to the hard upper torso. On the new suits that will be used for lunar surface missions, the lower torso includes advanced materials and joint interfaces that allows bending and rotating at the hips, bending at the knees, and hiking-style boots. With this new mobility, astronauts will be able to walk on the lunar surface instead of doing the bunny hop that was developed by the Apollo moonwalkers. One of the most important parts of the suit is the life support system. On the back of the spacesuit is a backpack that holds the supplies and equipment to make the suit work. This backpack contains the oxygen that the astronauts breathe and that pressurizes the suit. A regulator in the backpack keeps the suit at the correct pressure. A fan circulates the oxygen through the suit and the life support system, where the carbon dioxide that the astronauts exhale is removed from the suit. The backpack provides electricity for the suit and holds a two-way radio communication. The backpack also contains water for cooling the garment, a chiller to cool the water, and a pump to circulate that chilled water. Another important part of the suit is the helmet. The helmet on these suits serves as a pressure bubble and is made of strong plastic to keep the pressure of the suit contained. It also has a ventilation system that provides the astronauts with oxygen. The helmet also contains a small foam block that astronauts can use to scratch their nose, and I consider this one very important, as I've wondered, what do you do if you get an itch on your nose? Have you ever had one and not tried to itch it? Just give it a try. It can drive you crazy. Outside of this bubble is a protective visor that keeps the pressure bubble from getting bumped or scratched. On top of that protective visor are the sun visor and the sun shades. The sun visor has a special gold coating that works like an astronaut's sunglasses. Together, the movable sun visor and the sun shade protect the astronaut from the sun's strong rays. I wonder what their EVAs will look like. Maybe like this? And in the future, what will the spacesuits look like? According to the new design by MIT, they'll be more form-fitting, with a stretchy pressure layer on the inside. But according to some engineers that work with Nexus Aurora, there'll be a hard outer layer. This hard outer layer will apply pressure to the inner layer, allowing the correct pressure to be put on certain areas where it's needed most. This hard outer layer will also be protection on the outside during EVAs. Regardless of the design they end up with, I guarantee they'll look a lot cooler than they do today.
So you've done a lot of exciting research, design, engineering on spacesuits. What does the spacesuit of the future look like?
Well, if I have anything to say about it, it'll be a very tight-fitting suit. We use mechanical counterpressure to pressurize right directly on the skin. It seems that it's technically feasible. We're still at the research and development stage. We don't have a flight system, but technically it's feasible. So we do a lot of work in the materials. You know, what materials do we need to pressurize someone? What's the patterning we need? That's what our patents are in, the patterning, kind of how we apply this. It's a third of an atmosphere. Oxygen, nitrogen, to put a suit, if we put someone to a third of an atmosphere. So for mechanical counterpressure now, so one way is to do it with a balloon, and that's what we currently have. Or you can apply the pressure directly to the skin. I only have to give you a third of an atmosphere. Right now, you and I are very happy in one atmosphere. So you know, we can. So if I put that pressure, a third of an atmosphere on you, I just have to do it consistently, you know, across, you know, all of your body and your limbs, and it'll be a gas pressurized helmet. Doesn't make sense to shrink wrap the head. See the Blue Man Group? That's a great, it's a great act.
Yeah.
But we don't need to. You know, there's no benefits of like shrink wrapping the head. You put, you know, a gas pressurized helmet, because the helmet, then the future of suits you asked me about, the helmet just becomes your information portal.
Yes.
So it will have augmented reality. It'll have all the information you need. Should have, you know, the maps that I need. I'm on the moon. Okay, well, hey, smart helmet. Then show me the map, show me the topography. Hopefully it has the lab embedded too. If it has really great cameras, maybe I can see what that regolith, that's just lunar dust and dirt. What's that made out of? We talked about the water. So the helmet then really becomes this information portal, is how I see kind of the IT architecture of the helmet is really allowing me to, you know, use all of my modalities of an explorer that I'd like to. So cameras, voiceover, images. If it were really good, it would kind of be, would have lab capabilities as well.
And it's called the Zinger 21C. The Zinger 21C is an American-made hypercar designed by AI and built using 3D printers. Is this foreshadowing the way the automotive industry is going to operate in the future? Also, it learns through experience. And the more experience a machine has, the more data it has to interpret and analyze, thereby learning more information. And the second part is called decision making. Programmers will give the computer certain parameters to follow that are set out by the engineers and the creators of the car. And these are things like mounting points and size restriction, as well as strength properties. There are a ton of parameters that have to be factored in. So many, in fact, that when you build a car in the real world, it takes thousands of people spending thousands of hours and millions of dollars to do what a computer can do in a fraction of the time. You're basically defining the rules of the game and then pressing enter. It's very simplified, but you get my point. Now, AI can even account for external factors, things like wind resistance and gravity and other natural phenomena. And a result of this is that artificial intelligence produces some crazy looking designs.
Nature, obviously through trial and error and evolution, is very viciously competing for material and energy. Which is why, those structures have material where it's needed, no material where it isn't, and it looks like a leaf structure or, the internal structure of a bone, marrow, other things, right? That you have, say, a major automotive company will have all of its own load cases, road durability cases and other things. Say the machine is running those cases, selecting materials out of a database that have already been correlated, meaning physically tested against all of these different load cases, and is generating a structure. So then you have the most efficient structure for the case that's needed that uses the minimum amount of material, meaning you're reducing mass to the max and still meeting a performance set of requirements.
That's additive manufacturing, better known as 3D printing. Now, this method directly contrasts to subtractive manufacturing process used in the majority of the automobile space. It eliminates any and all waste associated with manufacturing because the process only uses the necessary amount of material needed. A 3D printer doesn't print out extra material. Now, the 21C is primarily manufactured out of aluminum alloy, titanium, and carbon fiber. So how do you print out things like that? Well, Zinger uses a method of additive manufacturing that incorporates atomized powdered metals in a high-powered laser that essentially melts the individual grains of the material together and builds the product one layer at a time. Once the first layer of material is created, the printer pushes a new layer of atomized metal material across it, and the laser goes back to work, making the second layer of material. It's like building a cake. Okay, you put one layer on, then you freaking put another layer on, then you put another layer on. The 3D printing is the only viable method for this sort of manufacturing because of the fact that the materials are designed computationally. There's no sort of tooling out there that can make these designs with the strength and structural integrity that's required for them to work optimally. It's just not humanly possible, which is why Zinger doesn't use humans. In the Zinger method, we're sort of obsolete. They took our job! Zinger doubled down on the obsolescence of the current car creation process and developed something called the automated unit, or AU. And that uses a bespoke assembly method called vertical assembly. One AU is a 50-foot by 50-foot set of robotic arms that work in total harmony with each other to fully assemble a car. Some of the robots hold the chassis of the car up and rotate it as needed, while the other arms take all of the pieces and parts of the chassis and then assemble them. The 3D printed parts get incorporated into the AU and assembled with insanely low variance. We're talking about 4/1000th of an inch of precision. So there's no friggin' door gaps on this computer car. It's tight, baby. Now the car as a whole takes about 3,000 hours to assemble, which, if you're wondering, that's 125 days. But the assembly of the structure of the 21C takes less than an hour. And the reason that Zinger can assemble the base of the car so quickly is because of all of these different bleeding edge technologies working together at the same time. Each robot can move at up to 5 miles per hour, which doesn't sound fast, but when you consider that the robotic arm can do that while holding an entire car, that sounds just a bit more impressive. And also, each arm is operating within its own set of objectives, while taking into account the objectives of the other robotic arms. Each one of the AUs operate as an independent manufacturing cell. It's totally autonomous and needs little to no input from people or other processes. Other than actually getting the parts, both 3D printed and otherwise, there's little that needs to be done with the AU other than pressing go on the computer that runs the freaking thing. A side effect of this sort of assembly is that the robots can be very easily reprogrammed to accomplish a new task or make a new product. Unlike the dies and presses currently used to make parts in the current manufacturing process, Zinger's AU simply gets reprogrammed to incorporate the new pieces or new process into the vertical assembly, making the process essentially as simple as clicking a button. Again, this is a computer that's doing all the work for you. The robot and the AU itself are design agnostic, which allows for the assembly line to be changed in a matter of minutes rather than a matter of hours. There's no additional tooling that needs to be installed. This is why a conventional assembly line can cost $500 million or more. Zinger's vertical assembly method is estimated to only cost about $3 million. Imagine being able to save $497 million in expenses, not to mention 9 miles of space. What would you do with $497 million? Put a link in the comment. I'd buy Nolan. This closed loop of manufacturing makes the AU scalable, which is where this concept really starts to show its potential impact as a manufacturing process as a whole. So as it stands, one AU can theoretically pump out 10,000 21C vehicle structures each year, and it costs a small fraction of what a conventional assembly line costs. However, the AUs are limited by the amount of space that's available for them, obviously, and as it stands, one AU takes up 2,500 square feet. Now, if we scale that up to say a 100,000 square foot warehouse, we're looking at 40 AUs, all working at the same time, which in their current state could make 400,000 car structures a year. That's almost double the amount of Corollas made just last year. Now, Zinger's approach to making a car is small scale right now. They only plan to build 80 models, but that's okay though, because the net result of all these bleeding edge technologies colliding underneath one roof is arguably one of the most advanced and insane hypercars that has ever been built. Like ever. As a car, this thing is just as bonkers as the methods used to make it. The Zinger team is constantly talking about how the SR-71 Blackbird was a massive point of inspiration for this car, which, if you didn't know, is probably the most amazing plane ever built in the history of making planes, even down to the front view of the car. It's meant to mimic the front view of the SR-71 and be as slick as possible to cut through the air like a razor blade. And from the front, it basically looks just like 3 humps and a few vents, which is remarkably similar to the plane. This copycatting comes as no surprise, considering the plane can go over 2,000 miles an hour. Zinger is coming out with 2 versions of the 21C, the first of which is a track-only variant that's meant to just absolutely smash a bunch of track records. It's yet to be seen, but we'll see. And the second variant is going to have less downforce and be a road legal car. And now, because it has less downforce, it gets super duper slippery and can achieve a top speed of 270 miles an hour from a 2.88 liter twin turbo V8 and 2 little batteries powering the front wheels. Not to mention, it can go 0 to 60 in 1.9 seconds. That's pretty quick. If computational engineering allows us to design cars that were otherwise impossible to design, and then 3D printing actually allows for those cars to be built, then cars are going to start getting crazy. And you can think of the 21C as the world's fastest proof of concept car. Thanks to everyone over at Zinger for letting us pick your brain. I got to speak to another CEO of a car company. That's two. Thanks to Jens, the Chief Commercial Officer, for all your help. Thank you guys for watching B2B. Follow us on Instagram at Donut Media. Follow me at Jeremiah Burton. Till next week, bye for now.
Objects take shape as if by magic, created one layer at a time by a machine. They can be made of plastics or even metals. Digital construction plans are swiftly brought to life.
We're in a whole new world now where we're merging software and material science.
A project can move from the drawing board to the finished product with remarkable speed. And three-dimensional printers use less material, labor, and energy as they turn out new designs.
It allows goods to be produced in lower quantities, more often, closer to the point of consumption.
This technology could have the power to revolutionize the flow of goods and the scope of product markets.
It's disruptive. We're destroying the old production methods that were used for decades. Now we're supposed to use 3D printing.
The great thing about 3D printing is that we can create parts that used to seem impossible. Classical manufacturing processes simply could not work with certain complex geometries, such as in furniture.
Or this gripping device for robots, which is based on the design of the human finger. The device is outfitted with flexible slats that provide a non-slip grip.
The fascinating thing is that our creative process is completely digital. Engineers can sit down at the computer and just design something, and their imagination is no longer limited by classical production methods such as sawing or milling.
Fast Radius often uses plastic resins, which allow for faster printing. The process looks like something out of a science fiction film. The metal foot dips into the resin solution. The components solidify on the bottom, as if by magic. No molds are needed. Light sources inside the solution ensure that only certain parts harden and take shape. This process makes the product lighter and also uses fewer raw materials. The company's co-founder and CEO is Lou Rassi. Fast Radius is working with logistics company UPS to completely rethink the concept of supply chains.
Additive manufacturing will have a profound impact on how global supply chains work. We call it the fourth modality of logistics, in fact. What we mean is that through human history, we have moved parts in three ways: by ground, by air, and by sea. And now we have a fourth mode of transportation, and that is moving parts by the internet at the speed of light.
Digital production offers a tremendous freedom to potential clients. A global 3D printing network can provide products more efficiently. Transport routes are shorter, and there are no huge specialized factories. These days, 3D printers can make just about anything, and robots automatically supervise the assembly lines. These machines can print single pieces or entire series of products, 24 hours a day.
First, in the materials. We can get about 20% of the atmosphere. Again, we need 30%, that's the design goal. Get about 20% with passive elastic material. That's kind of the white you're looking at. Shrink wrapper a little bit. We get almost all the way there, but we need something else. Active materials. So my doctoral student, Brad Holshoe, is coming up with some great work, shape memory alloys. You might know about them. They're nickel titanium. People like to call them muscle wires. They're pretty cool. So we need to shrink wrap a little bit more. So this is just a mock-up, of course, but zip, you push down there. All right, now I'm getting a couple extra centimeters there. So I can go from my 20 kilopascals to 30 kilopascals, voila. We have enough pressure, and we've just demonstrated enough pressure production with our active materials. But I still want her to be as mobile as possible. You saw those Apollo bloopers. Great technology for 40 years ago. We haven't improved much on the gas pressurized suits, so we can do better. How can we do better? Inspired by Iberal's early work on patterning, geometry. If you want to move around, very flexible, you've been patient, sitting with us all morning, move around a little bit, and if I drew circles all over your arms and legs, what would happen to those circles? Like in my animation, the circle would turn elliptical. And those two red lines, they're very special. Those are bisecting diameters. From the circle to the ellipse, they stay on both surfaces and they only pivot. They only rotate. They do not extend. Those are called the lines of non-extension. So we throw a little math at it, three-dimensional eigenvector analysis. Voila, the Spider-Man suit. That's the pattern of the black lines and the embedded gold lines you see here. This elegant math, engineering know-how, designs a wonderful aesthetic solution to give us maximum mobility and requires minimum energy expenditure. I want all of your energy to go into exploring Mars, not wasted in overcoming this big pressurized bulky suit. So we dream big. We want to enable humans. We dream of superhuman performance. I dream of a world with no disability. Let's just get rid of it. No one should have a disability, only ability. We need to celebrate the ability of humans because we can all perform and we need to enhance it. People need a little help. My Martian astronauts will need a little help when they get to the surface because of all that muscle bone loss. So we dream of superhuman capability. We work on it, inspires us every day. We're very inspired by exploration, by thinking about helping humanity, just one kid at a time, and then onward to my love and passion of design and engineering. So a final image then that I'd like to show you is one thing about the helmet, which we can display here. Second to final image. What's the day in the life of the Martian astronaut going to be like? You saw those mountains you have to go up and what you have to do, but we need to embed very interesting but complicated IT systems. So the IT system, you put on that helmet, put on your Google Glass. I wish it was Google Glass. It has to be a very enhanced version because we need to write our own code for it. We have the code, we just can't import it. Hal, how much? Sorry. But we're getting there. We'll be ready for the next version. Hal, how much oxygen do I have left? 60%, David. Good, good. Keep going. My rovers, my robots, they're all with me on this journey. I got to go down the slope, bring up a three-dimensional enhanced vision. Woo! What's that slope? 20 degrees. Okay, I can do that. Don't send the rovers down. That's 30 degrees right there. So we're all a team. Exploration is always a team, that you heard Diana say so eloquently.